The best sensation you get of changing the world is how you can create things that empower people to do things they couldn't do before.
The challenge is doing something new, but not for the sake of just doing something new, but because there's a big unmet need.
The research center here at GE is one of the most diverse industrial research facilities in the world. People with engineering backgrounds, physics, mathematics and modeling, artificial intelligence, chemistry, biology, imaging. I think that's the key to success and what enables us at GE to make advances that are difficult elsewhere.
The research center allows you to find areas where solutions don't currently exist, come up with a solution, and have that solution now become mainstream.
The first step in being able to treat the disease is being able to detect it and characterize it.
Whether it's the physics of X-ray particle movement or magnetic fields or radio frequency fields, that understanding of signals is paramount.
We're measuring every single X-ray photon and quantifying its energy. So that's giving us a much richer type of information.
We've been building MRI systems that's a one-size-fits-all. But then we started thinking, why don't we have a system that's specialized?
We've made ultrasound devices that are so miniaturized, they fit in your pocket and give you tremendously high-quality images that 20, 30 years ago you couldn't have dreamed of.
Instead of using traditional mathematics and statistics, we start to incorporate neural networks to give even better images and even further reduce the radiation dose to the patient.
Today, you cannot even think of making fundamental discoveries in sciences without digital.
Software is one of the key enablers that helps us to get our parts to the high quality, high tech, high robustness that we need for those really important applications. We actually do have parts that we are printing for aircraft engines. I take a couple pictures, it generates a 3D model, I can just upload the thing and print one.
We're building a whole new class of robotic systems leveraging AI that can actually go in and do the inspection, do the maintenance and the repair, which you could think of as minimally invasive surgery for complex machines, going into this concept of zero unplanned downtime.
Imagine you have a set of wind turbines. How do we establish the meaning of concepts so that they could have their own capacity to exchange experiences with each other and ultimately come up with a kind of communal wisdom, if you will?
With all these greener technologies and all these renewables coming in, it's like a synchronous dance. Energy storage has a huge future.
We're moving away from the use of permanent magnets and leveraging the same superconducting technology used in magnetic resonance imaging.
If we can eliminate the usage of the permanent magnet, then we save cost and we can improve the machine performance.
Really unlocking the novel crossover applications is one of the big benefits of the GE research team.
You have all these deep experts together trying to solve some of the toughest problems that have never been solved before.
What we are doing is just the beginning of something. We're just scratching the surface.
Because the problems are just so compelling and engaging and interesting and hard.
When you bring this collective team together, there's just something magical that emerges from it.
That's how you know you're in an area where you have the potential to change the world.
Hi, everyone. Thank you for joining today. We're so excited to have so many participants and amazing students from across the country joining us today. My name is Megan McGee. I lead talent acquisition for GE Research. We are broadcasting live with students from universities all across the country. So we're so excited today. You'll learn more about who GE Research is, a bit more on our mission to lead the global energy transition, precision healthcare, and a deeper look at how we're leading the future of flight. We'll also take time to talk about the programs we offer at GE Research, ways you can join us for a career, and answer questions that you have for us. Please feel free to put questions in the chat. We will be taking those at the end. We are also recording this session, so we are going to share it on our GE Research YouTube channel shortly after this broadcast ends. So we will have the opportunity to go back. If we miss anything and we go through slides quickly, we do want you to be able to share this and be able to talk to other students and learn more about us. So as we think about GE, we've gone through quite a transition to be a more focused, simpler, and stronger industrial technology company. So as we're looking at how we define the future of flight, as you can see with our aviation business, it's a revenue of $22 billion and 40,000 employees across the globe. So we're really a world leader of aircraft engines, avionics, electrical power, digital solutions, and services for commercial, military, and business aviation. Then as we're looking at how do we advance precision health, our healthcare business is an $18 billion business with 47,000 employees globally. And then we're leading medical technology, pharmaceutical diagnostics, and digital solutions in a very innovative way for healthcare. And then finally, accelerating the energy transition. Within our energy businesses, it's almost $39 billion in revenue with 90,000 employees. So really being a world leader in energy businesses, which include gas power, renewables, steam power, and nuclear. And really, we want to bring research to reality, which is we're learn a little bit more about how GE Research is the innovation engine for GE. So now I'll turn it over to Tiffany Westendorf, who will talk a little bit more about our history of innovation.
Hi, everyone. Thanks again for joining this session. My name is Tiffany Westendorf, and I lead the Edison program at GE Research. You'll hear more about the Edison program a little bit later in this session, but for now, I want to talk to you more about GE Research and GE's history as an innovation engine. Thinking back on the many different innovative technologies that have come out of GE and how many of them have originated at the GE Research Center, it's really inspiring. And when you think about what our mission is at GE Research, we seek to take cutting edge ideas and translate them into differentiated solutions for GE's businesses with an aim to deliver what the world needs. And when you look at GE Research, we are a unique research organization because our charter is research for a purpose. Fundamental R&D that advances scientific knowledge is great and highly valued. Our R&D is intended to be used by a real customer. And when you look at the way in which we deliver technology to the world through the GE businesses, the potential impact of our innovation is huge. GE aircraft engines power 2/3 of commercial departures. GE turbines generate 1/3 of the world's electricity. GE equipment creates thousands of medical image scans every minute. There is no better place for research to make a difference in people's lives. And when I think about where within GE is the best place to be in the company, it is absolutely at the GE Research Center. Our technical work touches all of GE's businesses and all the industries that we play in. And in addition to that, we are growing and expanding the work that we do with strategic partners outside of GE, like government agencies, other GE businesses that have now been transitioned to other entities, as well as other strategic commercial partners. And the idea behind those strategic external partnerships is to ensure that we are keeping in touch with technology trends and evolutions that our customers haven't yet thought to ask for. It is our responsibility at GE Research to see, move, and create the future and lead the way for our technology businesses. And what is exciting to me from a career standpoint about GE Research is that you can gain exposure to multiple industries without necessarily having to change jobs or organizations. So now I want to hand off to Satish Prabhakaran, who's going to talk a little bit more about some of the technology thrusts that we work on.
Thank you, Tiffany. As Megan talked about the different ecosystems here, I'm going to describe to you the different pillars that we have as our focal points. So if you think about the future of flight, there's going to be a lot of building blocks that we are developing to support the future product, right? And so today we have a lot of thrust within the commercial play as well as within the military play. So a lot of exciting technology that I will be talking about shortly after this slide. So hold on for a second there. In healthcare, if you're interested in hardware or software, there's plenty of opportunities that scan the breadth of driving productive, reliable, and effective healthcare solutions for our businesses. And then if you're somebody who's thinking about the energy transition, if you're thinking about carbon capture or carbon footprint improvements, then we have a lot of work that's going on between the renewables business, the nuclear business, and several other technologies there. I'd say overall, we are at the forefront of a lot of innovation that's leading and defining the future. In terms of where we work, very exciting. We have a very diverse mix of scientists and engineers, about 1,000 or so, with advanced degrees, a combination of PhDs and masters, as you can see, and also a wide variety of technical areas where one can insert themselves into. So for somebody like me who's been around for 15 years in the company, I've had an opportunity to actually work in every one of these pillars along my career progression. So it's nice to work here where you can actually stretch your imagination beyond one pillar, right? And overall, that then exposes you to the opportunity of inventing through patents. And today we have like a patent base of about 3,000 plus and continuing to invent, right? So having given that broad overview of all the technical pillars here, I'd like to talk about some of the work that I personally do. As background, I am the portfolio leader for the what we call as the hybrid electric aviation mission. And so maybe I'll give a background on the next slide in terms of what is this electrification of aviation all about. So if you think about decarbonization, it's happening across multiple ecosystems today, right? If we take on ground, if you take the electric grid, there's a lot of activity in terms of saving energy. And we have a combination of traditional gas or steam systems, but also combining with some new entrants like maybe electric systems like batteries. We're saving fuel, we're saving in efficiency points by transitioning to something that's a little bit more efficient, like batteries, for instance, could save from solar and wind and then help you use them in more effective ways. A similar thought process has happened in the transportation ecosystem. So if you think about locomotives or even electric cars for that matter, very easy to explain why we're making that transition. And these two examples are primarily ecosystems that reside on the ground. So a lot of work has happened over several decades in this space. Now I think it's coming to a point where we can leverage enough of the learnings from the other ecosystems to think about what we can do in the aviation space. So again, similar theme, electrifying the aviation space is going to get you more energy efficiency. However, now you got to have to fly these systems. And so there's a lot of focus on making these solutions lightweight as well as efficient at the same time. And in terms of scale, on the ground, we have vehicles and cars or even locomotives operating in the megawatt scale. What we're thinking about in aviation is also in the megawatt scale, except that we're going to have to fly them. So the next technology frontier is to miniaturize the ground-based systems to a point where they are flight-worthy. So maybe moving to the next slide, then more specific examples of what we have been doing on this front. In 2016, we demonstrated for the first time that we were able to propel a 1 megawatt system with an electric motor and electronics that powered that electric motor. This was our foray into this space to demonstrate for ourselves and then hence to the rest of the world that we have the technology to push the frontier with electrification. Electric propulsion was something new. So that was an achievement in 2016. It was a 1 megawatt. For scale, 1,000 kilowatts is like 1,000 horses. So that's exactly what we're talking about, the scale of 1,000 horses in terms of sheer force, if you will. And then another example is what's powering the motor. So next slide, you can see that in 2016, we had a rather large set of power electronics that was powering these motors. And now after 5 years of development, we're at a point where these things are starting to look like suitcases. So we're fitting 1,000 horses in a very small confined space. And just the sheer effort that it takes over the 5 years has been very exciting in terms of how that progression was made. So today we have something that's about 80x better than what we used to have back then, right? So again, a lot of technology going into miniaturizing all the conventional systems that you would otherwise see on the ground. And just to wrap up, I'd say it's not just about specific components that I talked about. There's a wider ecosystem of things that have to come in play and in place before we actually fly these systems in the air. So for instance, at the Research Center, we're very busy building out these components. But what's exciting is we're also very tightly linked to pieces of the business like GE Aviation in this case, where all the components that we build make a progression towards perhaps a more system level demonstration. And alongside that, we also have a lot of work that we do on the engine side, because remember, we're building out hybrid electric, which implies that there is a gas turbine working with an electric system. So there's a lot of work that we do on the gas turbine side to understand the entitlement of our electric system. And then we have also the ground demonstrators to prove to ourselves that this combination can in fact propel a fan. And once we do all of these, then it gives us perhaps enough confidence to go and attempt a flight demo in the exact configuration that it one day would be. So that's something out in the future, but we've got multiple steps that lead us to a future of safe flight with all these new technologies. And I'd like to acknowledge that it just doesn't take the efforts of one person or one company to get this done. We work a lot with the government agencies. So for instance, on the bottom right, you see representation by the FAA. We work with NASA a lot. We work with the Department of Energy a lot, because we have multiple programs that's funded by the United States government agencies that help us along the way in pushing this frontier towards a safe electric flight in the future. So that was all I had to share. I'm happy to take questions later, but now I'd like to hand it off to Suzanne Wolf, who will talk a little bit more about how to transition from universities into such ecosystems. Thank you.
Wow. Hi, everyone. Let me just say that was so awesome, Satish. What a walkthrough if you stop and think about what we just heard. That's great. My name is Suzanne Wolf, and I have to say, September 29th is here, 4 o'clock Eastern Time, and we're so excited to have this presentation for you. We've worked hard to put together information about our company, exciting information to share with you, and it's really great to have so many students with us on this broadcast as the numbers keep increasing as we talk. Now that we've shared who we are, a little bit about how we work, and some technology that we're working on right now, we're going to switch gears a little bit and talk about you. So what are you looking for? You're sitting out there, dorm room, apartment, maybe in the student union, and you're thinking to yourself, this sounds pretty interesting. So is it an internship? Are you enrolled in a bachelor's program and headed towards your master's? Are you midway through your PhD program? Or next summer, will you be between years 1 and 2 of your master's program? I tell you, we have roles for you, and we'll talk about each one of them in upcoming sections. I work on the talent acquisition team. My primary role is as intern program leader, and I work a lot with students from across the US and bring them here to GE Research, primarily a summer program. And sharing a little bit, thanks, about the program. It's generally a 10 to 12 week program, starting in May or June, going through July or August. Class size for us, we've had up to 70 interns, but really the sweet spot for us is 30 to 50. And we handpick each one of them for a specific technical assignment that we work with the student, with the Satishes and other technical managers to kind of identify what is the project that would further your education and really let you bring some of what you've learned in the classroom into a practical setting. We are industrial research, that's what we're all about. So it lets you see what a career looks like. If you've been hitting the books a little bit much in the lab, you get to actually see it in play for the summer, and it's pretty exciting. Challenging technical assignments, you are a member of a technical team, so you're alongside people who have been enrolled 2 years, 22 years, and those are your teammates on the project team, which is pretty exciting. Lots of learnings across the center, and when I say the center, that's the GE Research Center. A lot of learnings across the company of GE. We do a lot to educate and inform students about the GE aviation business, GE renewables business, GE Power, GE Healthcare, and how we work with them. Some professional growth sessions that you can get involved with and networking. We do a lot of things in our outdoor facility here. We do have one location. It is in Niskayuna, New York. It is in the capital region of New York State, about 3 hours north of Manhattan. So that's our one location that we bring our students into. And opportunities to explore the area. Every year our intern group does a really great job of, the off work hours and, what is there to do here in this area? And it's great to hear when we do our recap sessions on, different hiking that has happened and all kinds of exploring of the region. It's really great. I do have you can advance to the next slide. A couple of the interns that were here this past summer, we said goodbye about a month ago or so, stepped forward and said, I'd really like to share my experience. So I know the type is small and you can't really read it, all of them, but I just wanted to show the variety of students that we've had here with us. They really felt like there was value in their experience here as an intern. And it started to help them see the future and what's possible in terms of their careers and growth potential, and really help decide if a research career in an industrial setting is something that they're really interested in. We've had interns join us 2 summers in a row working through their PhD. And we do a nice job of pipelining into full-time opportunities too. So if you like this place, you like the people who are here and you're kind of digging the whole scene, there's opportunity to explore full-time opportunities too, which is super cool. I think that's it for my section about interns. We'll take any questions that you have at the end, and I'll hand off to Tiffany Westendorf, who will talk specifically about the full-time opportunity with the Edison program.
Hi again, everyone. This is Tiffany Westendorf, and as I said before, I lead the Edison program at the Research Center. So I'm excited to now tell you about this program that we hold. This is a full-time opportunity for employment that is a rotational program designed for master's graduates in engineering and computer science. And this rotational program is really designed to accelerate your research career. And on this slide here, you'll see a high-level overview of what the program offers. And really, the foundation of the Edison program is rotations and technical training. The Edison program is named for GE's founder, Thomas Edison, who's known for connecting the dots between technology and customer needs. And across GE, the Edison program consists of rotations and formal training experiences, and each business customizes the program for their own needs. So I'm talking here about specifically the Edison program at GE Research. And so in our program, as I said, the program is designed for master's graduates in engineering and computer science. The program is between 2 and 3 years in length, and in that time, you'll complete 3 rotations of about a year each. In year 1, you'll start your first rotation, typically with a group, a technology organization at the Research Center that is aligned with your background. So if you did your master's thesis in machine learning, then we would pair you with our machine learning and artificial intelligence research group for your first rotation, most typically. Also in your first year, you'll take a course, which is like engineering according to GE, where you'll gain exposure to GE technology and engineering fundamentals as it connects to GE's products and services. Each week is a different topic taught by a different GE expert. And if you think about it, you not only get that great exposure to GE technology and fundamentals, but you also build your network across GE research while learning that technology. In year 2, you'll transition to a new rotation in an area that offers a new technical perspective. And so that could be a stretch rotation in an area where you're maybe a little bit less familiar, or it could be a different aspect of a technology area that is closer to your background. And so in either way, that those additional rotations give you an opportunity to build both technical breadth and depth in your experiences. Also in your second year, you'll do B course, which is our independent research project. You choose a topic on that meets a customer need that where there's a difficult research problem to be addressed. You will define the scope of that technical project. You will engage stakeholders to help coach you and mentor you on the technology, as well as help you connect the dots to a customer need. And you'll practice ideation, innovation, and technical project leadership in the course of that 6-month project. Throughout the program, you will also engage in formal leadership training experiences to grow your business acumen and professional skills. And you'll have access to customer immersion experiences to both expand your network and deepen your expertise in GE's products and technology, and just better enhance your ability to connect the dots between technology and what the world needs. Upon completion of your 3rd rotation in the program, your next step is to transition into your first off-program role, which we hope will be a role as a research engineer at GE Research. So now that I've given you an overview of what the Edison program structure has to offer, I'd like to hand it off to one of our current Edison program members, Becky Sandelsky, for her to share her experience in the program.
Hi, everyone. I'm Becky Sandelsky. As Tiffany mentioned, I'm currently in the Edison program at GE Research, and I graduated with a mechanical engineering degree from a small private college in Milwaukee, Wisconsin. And then I specialized in heat transfer and thermodynamics in my master's degree, also in mechanical engineering. And I've really been able to follow my passion of heat transfer through the Edison program. My first rotation was with the Thermal Management and Systems Technology group, and I was working more on the analytical side of thermosciences. I developed a model for supercritical CO2, specifically for a flow loop that we were using to test heat exchangers. And I was able to exercise that model to help size and source some of the components and develop a plan for our testing. And then my second rotation was with the component heat transfer group, where I got to dabble a little bit with the experimental side. It was completely new to me, and I've learned so much about experimental design and post-processing of data. I've been experimentally testing the benefits of additively made turbine blades and what we can do to change the internal cooling passages to make the cooling of the turbine blades more efficient. And I'm currently transitioning into my 3rd rotation, which is going to be based at GE Aviation. And I'll be working with their advanced military team, looking at designing some auxiliary components that they use in order to kind of reuse the commercial engines in the military space. And the Edison program is more than just the technical work aspect. I've really found a lot of close friends through the program. There's a lot of trainings that we do, and Tiffany mentioned A course and B course, that you really get to know the other Edisons, and there's offsite outings like mini golf, and also opportunities to volunteer with fellow Edisons and There's sometimes an Edison soccer league and a lot of hiking and other activities that we do together. So back to you, Tiffany.
Becky, thanks so much for sharing your perspective and experiences on program. And one thing that I want to highlight is that this is a program that attracts students from all over the country. And so some of the community and team building activities that Becky talked about are, I think, just a really great reflection of the natural community of folks that's formed when you have people who have relocated from all over the country to start a new job and a new chapter in their career. You know, you have that kind of natural cohort of folks who are in a similar stage in life. And I think that in addition to the career experiences are what make the program so special. So if you're hearing all of this and you're thinking that this might be something that you're interested in, let's talk about what we look for in an Edison candidate. And so we do have some required qualifications for this program. One of those requirements is that you must be a master's student graduating for a full-time position, or if you are looking for an Edison internship position, we expect that you'll be enrolled in a master's program or, you know, strong intent to enroll in certain cases. But that master's student is really the target candidate for the Edison program opportunities. Due to the nature of our work, we do require permanent U.S. work authorization for all U.S. positions. That means that for the Edison program, we will not provide visa sponsorship for full-time or intern Edison roles. If you do have work authorization in India, you might be interested in an Edison role at our GE research facility in Bangalore. And if that is something that is interesting to you, I would recommend that you search ge.com/careers for that job posting to get connected in with that team. Academic excellence is a must, as noted by the minimum 3.0 GPA on a 4.0 scale. We seek our target engineering majors that we're interested in are computer science, electrical engineering, mechanical engineering, chemical engineering, and material science and engineering. And then if you look at the desired experience, what are the things that would make you stand out as a candidate? We're looking for people who have a passion for R&D, working on tough technical problems that no one may have solved before. And one of the things that characterizes a research problem sometimes is that the problem may not be extremely well defined. And so part of solving the problem is really understanding how to define the problem and break it down into pieces that guide your discovery and innovation. We ideally are looking for people who have some previous work experience, especially if that work experience is research-based in nature. That research experience could look like an undergraduate or a graduate research experience at your university. It could be a research experience at another company or a national lab, or it could be a non-research work experience at another company. We seek analytical and creative problem-solving skills, excellent communication skills, and exceptional interpersonal leadership and collaboration skills. And when we think about how we might start to interview candidates, if this is something that is very interesting to you, we do accept applications for the Edison program on a rolling basis. We are now starting to recruit full-time Edisons to start in 2022. And we will begin, we actually are just starting to recruit our Edison interns for summer 2022 as well. Just a quick look at our interview process. We do have a multi-stage interview process where you'll have the opportunity to let us get to know you better, and you'll get to know us a little bit better on a personal basis. The first round interview is an introductory phone interview where we would love to hear more about your career goals and your research interests. And we can take that opportunity to answer any specific questions that you may have about our program. The second round interview is a technical phone interview where you will speak with GE research technologists who work in your area of interest. So if you are a mechanical engineer who's focusing a lot on structural analysis, we might have you meet with some researchers in our mechanics and design organization, as an example. The format of that phone interview is that you'll share a 15-minute technical presentation that shows off your research and problem-solving skills and expertise, and that will seed a technical discussion for the interview session. So those first two rounds of the interview process are the same for both our interns and for our full-time candidates. And for those candidates who are seeking a full-time role in our Edison program, we do have a final round interview, which normally would be an on-site interview where we would invite you to Niskayuna to see our facilities. And in this time, we are conducting all of those interviews over Microsoft Teams in a virtual interview day. But in that interview day virtually, you will meet again with GE Research technologists. You'll meet with current Edison program members, and you'll meet with various aspects and members of the GE Research Edison program leadership, so that you'll have a chance to talk with a lot of different potential colleagues, get your questions answered, and also you'll have the opportunity to showcase your research capabilities in a 30-minute technical presentation. And that's a really great way to introduce yourself to the folks that you'll be interviewing with for the day. And throughout this process, we look forward to the opportunity to both get to know you better and also for you to see for yourself what GE Research has to offer. And so in conclusion, I'll just flash up on this slide that really summarizes the program structure and what our active job postings are for the Edison internship and full-time opportunities. Thank you so much for your attention during this section, and I hope that you've heard something that interests you about our program. In my 17 years at GE, the people have really been the best part of my experience, and I look forward to seeing your application to our postings, and I hope that I have the chance to speak with you more and welcome you into our team at some point in the future. And so with that, I'd like to hand the mic back to Megan to talk a little bit more about entry points for our PhD students.
Great, thank you, Tiffany. So you've heard about the master's track with our Edison Engineering Leadership Program. So now we're going to switch gears and talk a little bit more about the PhD track for direct hire roles into GE, both at the full-time and the fellow internship opportunities. Just like Tiffany had Becky kind of do a discussion point as an Edison, I'd like to also turn over to Han Xiang, who will talk a little bit more about, he did an internship at PhD, he did as a PhD, he did an internship at GE Research and then joined full-time. So we really want you to hear Han's story and journey with GE Research. So Han, I'll turn it over to you here.
Of course, thank you, Megan. Hi, everybody. My name is Han Xiang. I am a lead engineer in the electrical systems group, and this is my third year at GE Research since I joined in 2019. So I got my PhD degree from The Ohio State University in 2019, and since then joined GE Research right after. But a year prior to that, in the summer of 2018, I took a semi-intern position in the dielectric and insulation group at GE Research, and in retrospect, it was certainly an awesome choice. And I'm here to share exactly that experience and that transition from an intern to a full-time employee. So a little bit of technical background here. I worked mostly on electric machine installation and machine drive and control systems at OSU. Here's you see the bottom left, here's a photo of my lab setup back in grad school. Go Buckeyes. Because of my background in electric machine and installation, during my internship at GE Research, my main focus was actually to help with the installation design and monitoring in GE's effort towards hybrid electric aircraft propulsion. So as you've heard from Satish, GE as a world leader in aircraft engine manufacture has established an awesome technology path towards aircraft electrification well ahead of others. And then GE Research really has been at the very center to push this technology forward. You've seen this this photo in the middle, already 1 megawatt electric machine driving and propeller, but this really is awesome technology. So aside from exciting technologies, I particularly enjoyed my internship at GE Research because of my colleagues. So two extraordinary characteristics that stand out from almost all my colleagues here are that, first of all, they are genuinely nice human beings in and out of work, and that they are so knowledgeable in what they do. And because GE Research has folks working in so many diverse domains and topics in the realm of science and engineering. There's hardly a time where you have engineering related question but cannot find the right person or expertise for within GE research. There's really hardly a time for that. And this is not a statement you can make with too many R&D centers. In addition to awesome people and technology, the area where GE research is at, as you've heard, is in New York, also has tons to offer. The long summer days during my internship here really was never boring. I took the three photos you see below. It's a great area for hiking, and Arondex is right up there, up north. A lot of outdoor activities, golf, mountain biking, and all that. Also close by is the summer home of Boston Symphony Orchestra in the top right photo, or not top right, but in the second column, if you will, top right photo there. This is Niskayuna is also close to the summer home of Philadelphia Orchestra. New York Philharmonic is just down south in the city. You have access to 3 out of the big 5 orchestras in the States if you like concerts and classical music. So at the end of the internship, I was offered the full-time position contingent upon completion of PhD degree. I believe Megan will walk you guys through the process, including the reviewing and hiring later in the next couple of slides. A couple key points I want to hit here is after being with GE research full-time for some time, is that the first thing I want to highlight actually is the team rapport within GE research. You see a group of us in the top right photo, a group of us actually coming on site, following mask guidelines, of course, surrounding and engineering prototype, debugging and discussing together to try to identify some issues we were having. We work on amazing technology as a team. That's what I'm trying to, that's something that I can really feel here, the team rapport. The second thing, which I've mentioned before, GE research has so many different domains in science and engineering, and from a personal growth perspective, I was able to get exposed to a lot more exciting and enabling technologies in addition to the electrification of aircraft we talked about. If you're impressed by the videos at the beginning of this session introducing GE technology, try imagining actually getting to work on it. So the last one, the last key point I want to hit is that the area is even more fun in winter now that you get to spend winter here as a full-time. I'm not a stranger to snow after a couple of years in Columbus, Ohio, but here you can actually explore in snow and in the cold. You can snowshoeing, skiing, or just literally jump in the snow like I did, shown here in the photo, which is, this is not something that I can say. Or winter is particularly not something I enjoy back in Ohio, but I really do enjoy the winter here. So all in all, I truly highly recommend GE Research as a place to do internship and full-time if you get the opportunity. It's not everywhere. You find smart and nice people to work with. So with that, as promised, I'll turn over to Megan for more details on the candidate interview and hiring side of things.
Great, thank you, Han. And of course, we're so delighted to have Han. As you can see, we get to hire great people like him who represent us every day and helping to impact the world and also making it a great place to work with amazing colleagues. So as we look at PhD roles, it's a bit different from the Edison program. So as Tiffany mentioned, it's a leadership program with one position that you would apply to for either the internship or a full-time position. For our entry-level PhD roles, you'll actually see specific roles that you would apply to based on your experience. So if you see something obviously that has the requirements for the type of degree and maybe the thesis work you have, you would apply directly to the role for a researcher role. Again, must be a graduating PhD for full-time and then enrolled in a PhD program for the fellow internship program. We do sponsor at the PhD level for both full-time and fellowship intern roles, depending on the position requirements. So for example, there are roles that require a US person based on government work or export control, but we do have the ability to sponsor at the PhD level, which is different than the Edison program. Again, all of our roles everywhere, master's, PhD, we all look for passion, aptitude, for a desire in research. We work on very cross-functional teams, as Han spoke to. We really want an execution mindset with the ability to work across all functions and levels as part of a team. So then as you look at the interview process, again, much like what Tiffany described, that you would have typically the introductory phone interview, a technical phone interview, and then what we're calling our on-site interview. Again, in this time frame, it is virtual, but we do treat it as a full interview day to give you a vast experience of what truly would be an on-site experience so that you have the opportunity to evaluate us. Obviously, we know you're doing that as we are looking to hopefully sell you in a role that you would want to join with GE Research. We are now recruiting for the summer 2022 fellowship intern program. So you will see that there's a position posted out on our website for the fellowship program. And then again, for the full-time roles, if we go to this last slide, you'll see these are the main areas that we're hiring. It's not all of them, but we're doing a bulk of hiring in controls and optimization, mechanics and design, thermal sciences and materials. And then you'll see just a slice and sampling of a few of the roles on the right, just to give you an idea of when we say as a PhD, you would go apply for a particular role. Obviously, again, if you were focused in AI or machine learning, you would see that there's a research engineer position that you would go ahead and apply directly to. So again, there are roles and you'll see more. We would love for you to follow us on Twitter, LinkedIn, take a look at our website, and we hope you're interested. We hope you'll apply. And again, I will kind of end here so we can get through the end to take some questions. So Tiffany, I'll hand it back over to you to kind of close out on our portion here.
Thanks, Megan. So Megan and I both spent some time in this session talking you through what we're looking for when we are seeking candidates for our Edison program and our PhD direct hire roles and our internship programs. And we threw a lot of the information at you. So just to summarize, we talked through our different entry points. We are looking for outstanding students across multiple engineering majors that are listed here. We are looking for people who are interested in working alongside our amazing colleagues and technical mentors to join our team located in Niskayuna, New York, to see, move, and create the future. Visa sponsorship is available only for PhD roles, and U.S. work authorization is required for all U.S.-based master's roles. Some of the work that we do does require a security clearance, and if a role that you're interested in requires clearance, it will say so in the job posting as a requirement. I'll say specifically for the Edison program, security clearance is nice to have, but not required. And there are some PhD roles where security clearance is a requirement. And so with that in mind, and this summary, we have got a healthy list of questions in the Q&A section. And so I'm just going to kick it off and start taking questions. You may, if you've looked at the questions field, you should see that there's an ability for you to like a question that you are especially interested in. And so if you haven't liked a question that you also are interested in hearing the answer to, please do that, because we're going to look at the questions that people have upvoted the most first. So with that in mind, the most upvoted question at this time is if GE sponsors F1 visa holders to work on CPT or OPT. I think that maybe Megan would be best to answer that question. I kind of addressed it, but Megan might have some more details.
Yes, thanks, Tiffany. So good question. So again, we do sponsor F1 folks that would be on OPT at the PhD level. You will see it in the basic requirements of the positions that are posted if we have the ability to sponsor. So we do at the PhD level. Unfortunately, we don't at master's and below, just because of immigration complications and things like that. We have some options with outstanding researcher visas and things of that nature. So yes, we do sponsor we have an immigration specialist. Actually, we have a very international community, so it's very important to us to have representation from people from all over the world. And again, only when we have some restrictions on export controlled work or government work where we can't, you'll see in the job requirements if it's required to be a U.S. person. Okay. So I'm hoping I'm seeing the next question here. What if I applied for a full-time recent grad position When would I hear back from GE, not the Edison program, but an engineering recent grad position? So I'm assuming, I'll take this one. I'm assuming this would be with GE Research. I have a team of recruiters, not a big team. So we try to get through candidates that apply as quickly as possible. We do try to get back to you in as quick as manner as we can. And so I would just say that we will try to get back to you from a recruiter, or at least something, you know, as quick as we can. Unfortunately, the timing varies based on the role. Okay. All right. So then let me take another question here. I see I'm not looking at these right. So, okay. How should a PhD apply for a full-time role? How long does the interview process take? I'm going to ask Han. I would love to hear, obviously you went through the process. I would just maybe advice to a student on how you went about finding a role, right? Because obviously you'll see the roles here, and how you kind of went through the interview process. Maybe your experience, Han, on students applying and getting into an interview.
Yeah, of course. I'll talk about my experience a little bit. So how early should a PhD apply for a full-time role? I think I'll still address that. Megan, since I was more in I was offered a full-time at the end of my internship, so I did not go through that process, but I did go through the interview process for internship, and I believe so. To me, there are two main ways you can get more knowledge or get the updated news on the positions that are open here at GE Research. So first, of course, the GE website. We have a career website that's wonderful. Nice search functions. You should be able to look for the information there. And the second, which is also the second way, which is how I got the information, was actually through the academia world, where the academia world really is not that big, and when a place like GE starts a position, you get to hear it from your advisor, from your coworkers in grad school. Yeah, you get that kind of information. So the first one, how for the full-time interview or the full-time role, I'll address it back to Megan.
Okay, thanks. Okay, so for full-time, again, please go to our website. We would definitely recommend. We don't get I know people feel there's a black hole. I will say we don't get a huge abundance of people that apply to roles. So we really do go through and look at the resumes that come in. And so I think the one good thing is we're probably the one part of GE that hires at the PhD level. So just go in and apply. Like I said, we are hiring and we're moving quickly, and we're going to keep hiring. So definitely recommend just going to our website, which you'll see ge.com/research, and apply to a role that you see that might be a fit. Okay. So next question here that I see, I'm curious what mentorship and laboratory groups look like within GE Research. Are labs structured into groups headed by a PI like in academia? Satish, since you've been a technology manager, you're a platform leader, could you take that one and maybe provide some insight there?
Sure, Megan, no problem there. Yeah, that was a good question, and not far off from the comment over there. Yes, indeed, we are structured logically into groups that follow a mission. So for instance, within the hybrid electric aircraft mission, we have subgroups, and each one of them is thinking about a different technology. So there's groups led by project leaders. And at the same time, I'd say that you're not limited to one group, right? That's the nice thing about perhaps coming in as an intern. You have the opportunity to work across multiple groups, and I'd recommend that because this is your turn to kind of feel out what you would like to learn or what you're most passionate about, and that comes just from the variety of things that you work on. So groups typically report into what we would logically call as laboratories. So we have lab managers or technology managers. I myself was one of them, like Megan said. And then we're structured such that we just report into broader organizations over here. So overall, I'd say lots of labs. I'd say if I had to just go rough count, we have about 50 labs that span the breadth of those three pillars that we talked about earlier. Thank you.
Good point of view on that question, Satish. Just to pile on there, one of the ways that I compare our organization structure is a little bit like a university. You know how there's the mechanical engineering department and the electrical engineering department at a university? We're a little bit like that, maybe a little bit more focused. So we've got the mechanics and design organization within mechanical engineering that's like hard things like structures and mechanical systems, gears, things like that. And then we have the thermosciences organization, which is more like the soft side of mechanical engineering, like heat transfer, fluid flow, CFD, things like that. I'm going to take the next question that's been upvoted. As a master's student, do you need to have a thesis? And the answer is no, a thesis is not required. It is highly desirable though, because it is one means by which you demonstrate that you have research experience and experience in taking a problem that is maybe not super well defined and breaking it down into a series of problems and exploration problems to solve along the way towards demonstrating your research skills in your thesis. So thesis is not required for masters and is highly preferred. So if I look at the next question on the list, I'll read it and then what makes a candidate stand out to you when looking at applications for GE research from a university? So for this question, I want to pass it back to Suzanne because she does a lot of resume screens for our intern program.
Yeah, sure. Happy to share. And that is my life lately. I have a resume bandwidth, I think, of 30 to 50 per day. So it's been fun. And, you know, the things that we're looking for is demonstrated passion on paper before we get to talk to you about with technology and innovation, regardless of majors. So certainly mechanical engineering, material science, computer science, electrical engineering. Those are the four big buckets, but we know as you get into the grad programs, you start to specialize a little bit from there. So we want to see that you've had ability to get into research opportunities at your university. For the Edison program specifically, we also like to see other things that you have a passion for that lend to your leadership potential, other things that you're involved with and make a commitment to. So those are all kinds of things that we look for. We do have a standard threshold of a GPA 3.0 out of a 4.0 scale. So we do observe a GPA calculation on resumes too. And, you know, internship experience is preferred to join as a full-time, but not required. And I think those are like the highlights that we look for. Yeah. Switching gears a little bit. So the next question, what skills does GE value most in those applying to positions directly after a PhD? So I think I'll turn this back to Megan because she does a lot of the direct hire oversight at the PhD level.
Sure. Very good question. All of these are very good questions. This probably piggybacks really well on what Suzanne just mentioned. On, you know, what do we look for in candidates is very much the same things that would make you stand out, right? So we look for, again, passion, for innovation, for curiosity, and looking to ways to solve problems, and having a strong record of, different internships and different things that you've done, worked on different experiences. I think like Han said, having a great relationship with your advisors and your professors. We rely heavily on our academic partners on sending us referrals and working specifically with universities on, hey, we want to partner more. We do a lot with the universities too in terms of proposals for government work. So there's a lot of opportunity too for students who say, hey, I would love to work on something, NASA, is obviously how cool would that be? So we have a lot of joint work that we do with universities in terms of research, and then in particular on joint work that we do to solve the problems for the world with the U.S. government agencies and things like that. So so there's a lot of things, and I know we've shared a lot today. So hopefully you've had a chance to soak some things in. I know there's further questions that we didn't get to, but again, we would love for you to, again, take a look at our website to apply to roles. Follow us on Twitter. We have a LinkedIn GE research page. And to close out again, we appreciate your time today. I want to thank everybody on the GE team for presenting some great experiences from their careers and being able to provide the flavor of what they bring to GE and why we have them here. So to close out, again, we are hiring for all areas, both at the master's and PhD level, and you will see those again posted. And then I have recorded this session, and you will see it shortly on our GE Research YouTube page. So if there's something you want to go back and look at, we will welcome you to do so. And obviously feel free to share with your friends. So with that, I know we are a minute over. So again, thank you. We hope that you would like to come join us to, again, help impact the world and see how we move and create the future of industries and the future of the world with GE Research. So thank you, everyone, and have a great night.